Hi, I'm Jeff from Proplanner, and I'm going to be giving an overview of our manufacturing execution system. But to start us off, I want to go over just this quick presentation about an overview of Proplanner. I'm just going to touch briefly on our authoring environment, but for more details on that, there are other videos you can check out. So, what is Proplanner? Proplanner manufacturing execution allows manufacturers to use the processes they author for model option complex assemblies and execute them on the shop floor, where all of the model option complexity is managed by our execution system in our authoring environment, as opposed to all of the model option complexity being handled within the shop floor devices. So when processes change in Proplanner, everything moves modularly and can be interchanged if devices are set up that way. As opposed to other systems where you need to handle that complexity within the device and need to reprogram it every time a new model option is available, or if new things are going to hit the manufacturing floor or be manufactured elsewhere. So all of that model option complexity is handled within our system. And to go into just a quick overview of the authoring side of Proplanner, I'm going to direct your attention to the top right of this slide here to just kind of go through some of the terminology from our authoring environment. So everything is grouped under a routing, which is the biggest umbrella for all the tasks to be executed within a process. So routing can be treated as an assembly line or a product option, but really anything that you want to group a bunch of different tasks under. And then within that routing, there are activities, which are what drive the model option configurability in Proplanner. Within activities, you have work steps, which are the individual tasks to be created within an activity. So to give an example, an activity is torque these bolts. Work step 1 could be to fixture the part. Work step 2 could be grab the bolts, and work step 3 could be torque the bolts. So those are the finest parts of the process that you want to execute on the shop floor. And then all of that can be grouped into operations, which could be thought of as stations. So that groups activities together within a routing and can be assigned to different operators to execute. So just to kind of go through how to set up a bare bones process in authoring, first you would define a routing, then you would define operations within that routing, which are groups of assignable work. Then you would define activities within the operations, which are model option driven events. Within each activity, you would define the work steps, which are the individual tasks that need to be executed to complete that activity. And then there are resources, which are thought of as devices. So in the graphic in the top right, I show resources being mapped to all kinds of work steps. And that's because resources can be used amongst all work steps. You don't have to stay in one work step with one resource. And resources are devices or tools to be used within a process. So to go into a little bit more detail about the resources and devices, a resource is a device in combination with its parameters. So a resource can be thought of as not only the torque tool, but the job that the torque tool is running. So a resource would be torque tool 1, job 1, as an example. A device name links the resource to the physical tool on the line, which is defined in shop floor viewer when you have connection properties like IP address and things like that. So I've got an example of that up here, where the resource in Assembly Planner has a name, DC Torque 1. And with that, I'm defining the parameters within that resource, so job 2. And then on the right side, I've got DC Torque 1 defined in shop floor viewer with its IP address and port mapped. So that gives us the flexibility of say you have a DC torque 1 in multiple different stations and want to use it amongst those stations. It only needs to be authored once within Assembly Planner, and then your connection properties for each of those tools at each station can be added in Shop Floor Viewer to be able to have that flexibility to move it around. So once again, the complexity of model option driven processes is controlled by us as opposed to being controlled within the shop floor devices. So as I mentioned, the parameters define how to execute a device. So that's the torque job, that could be what lights to light up on a tool tray, and what scanner to use and so on. Multiple resources can reference the same device. So an example would be the device is the torque controller. We can have multiple resources, one for each job referencing that device. And then resources are assigned to work steps, like I mentioned earlier. And then when a work step is executed on the shop floor, those parameters that are defined within the resource are sent to the device for execution. So once I get to the work step that uses this resource, job 2 will be sent to the torque controller. Now to go take a step back and look at the whole of all the Proplanner applications, this is just to kind of visualize what the whole software suite looks like and where it falls into the manufacturing process. So we were taking a look at Assembly Planner, that's the process authoring. When processes are completed there, they're published to the shop floor viewer, which is where you view the work instructions, and that's where you execute the processes as well. As you execute the processes, we go to the IoT service, which is what handles the communication between the shop floor devices. The IoT service is an application running on the shop floor, communicating with all of these devices. And then throughout these processes, as we're executing, we're recording all of the information associated with that process. So not only device results, but when units are completed, who's completing them, if issues are raised, and so on. So that's being recorded, and that can be monitored via FactBoard, which is our Andon dashboard application, which helps visualize the current status of the processes that I will show later in the demo. And then once all the processes are said and done, you can report that data and access it through a Power BI connector, which allows for production data visualization within Power BI. And before I jump into the actual demo, I just want to give an overview of all of the devices that make up this workstation. So this is made to mimic a 2-station assembly line. So I have 3 touchscreens. These 2, the left and the top, are running on a Intel NUC, which is a miniature PC running Windows. And then this one on the right is running on a Raspberry Pi, which is running Linux. And then I've got an Allen Bradley micro PLC connected to buttons and switches, and then an Allen Bradley PF4000. So I'm going to continue on to the actual physical demo in the next video. All right, so to move into our physical demo showing the execution of a process that I've made in Assembly Planner, I'm going to start by showing what I've got up on the screen. So shop floor viewer on both screens. This is logged into station 1. This is logged into station 2. And then I've got FactBoard up on the top screen. So I'm going to start by signing on to a unit in station 1. And then I've got my process tree showing operations and then the activities within those operations. I'm going to sign on to the first activity in there. And as I sign on, I get to the first work step, which includes a device asking for this button to be pushed. So an operator confirm. And then I've also got a work instruction here. And then I can start the process here. So I'm going to hit that button first, and then it'll call the Atlas Copco tool, calling it with job 1, which is model option driven, because this particular hub has 5 torques. So I drove the torque job with the model option configuration in Assembly Planner to call this one specifically for this model. So I'm going to run through these 5 torques. And as I'm going through, it's updating the work instruction screen with my current progress through the torque cycle. And if I fail one, it'll reflect it on the screen. And what I can do from the shop floor viewer screen is I can say I want to add or raise a hot issue. So add a hot issue. I'm going to call this a quality issue, and then say bad torque. And along with that, I want to attach camera image. So I've got a camera attached to this PC. I want to attach this image to that and save it. So now that I've had an error, I can save that hot issue and then go back and resume my process here. And since I raised the hot issue, it'll reflect on fact boards. So it shows that I've mentioned something, the operator has found an issue at this station, and posted it to fact board so that anyone that needs to know that's watching this dashboard can know what's going on at the station. So if I get it all cleared, I can go back, clear out this hot issue. So it shows bad torque as I recorded. I want to close this issue and then go back to finish my process. And then it'll move to my last device, which is a tool tray. And I'm going to flip the switches to make that. So now I've finished off this activity, and I can sign off. And now I've completed this station. So I'm going to move on now to the next station. Sign on here. And Factboard is reflecting now I'm signed off on the first station, and as I sign on to the second station, it'll update with my current status there. All right, so my first work step is actually asking me to loosen all these nuts on the hub, so I can hit yes or no on the screen whether or not I've loosened them. And then after I've loosened them, it activates a scanner device, which is a USB scanner hooked up to the station. And I'll use this scanner to scan a barcode, and that'll complete the process. So now I can sign off there. And now my process is complete. Here's a more detailed example about some of the more advanced functionality when you sign on to an activity and you have a CAD model loaded in. So there's a 3D CAD model associated with this process in Assembly Planner, and I can annotate it so I can put in text boxes, I can pan, move stuff around, I can add squares and mark it up however I want. I can do sectional views. And show whatever I want here. So if I create a sectional view and maybe circled, I'll create a sectional, circle the top, and then I can take a snapshot of whatever I just circled and then save it. And now that image is saved within my unit documents. So this annotation image can be fed back into the authoring system, and the engineer now can take into account the operator feedback on this annotation into maybe their next published set of work instructions or next quality report. So this document is now logged within that process. I'm going to show what all it takes to get the test bench set up and going. So I'm starting from a state where everything is off. Both of my tools have been turned on, and now I'm going to start powering up my PCs. So the Raspberry Pi on here has a switch on the cable that you can click. The two NUCs are on the back and have a push button on the front of each. So I've hit both of those, and they should begin powering up. And while we wait for things to power up, the barcode scanner is plugged into one of the NUCs, so that'll power up with the NUC, and then everything else is independently powered on the same socket strip. So now that we've got everything up, the first thing on the Raspberry Pi that shows up is just the desktop. There's no login there, so you can hit the browser, which is the globe icon in the top left, and that'll pull up the browser. And then on both of the NUCs, you swipe up or click, and then you can type in the user account. So this is user. And then if the touchscreen isn't working out, there are keyboards underneath. So each of these screens has a keyboard and a mouse assigned to them with labels on the front. And since the keyboard doesn't seem to be working, or the touchscreen doesn't seem to be working, I'm gonna reset the screen. So the first thing that shows up in when you open the browser on the Raspberry Pi is Shop Floor Viewer, so you can go directly and log into Shop Floor Viewer, and the same with the NUCs. So the NUCs, when they start up, will open Chrome, Chrome on both, and then on the top one, it'll open Chrome with the FactBoard application, the user manual for the test bench, and then also the presentation for the overview. So with all of that open, I can log in. So the login is the Cirrus login, and then the account for the computers are user for just a generic local account. So I can log in. And if the keyboard doesn't show up, there's a pinned keyboard on the bottom. So sometimes with the touchscreen interface, the keyboard doesn't show up in Windows. So you can hit the keyboard button down here and it'll pop up this on-screen keyboard. So now I'm all logged into Shop Floor Viewer and FactBoard. Re-log into FactBoard. And just to verify everything's up and running, the IoT service should be started up with one of the NUCs, but we can check to see all of the devices are connected. So I'm going to go to the administration page, IoT devices. It'll show IoT services when you first go into this page, but then you can go right into IoT devices. And I can see that I'm connected to everything, but I have an error on the torque tool. So what that means is I might need to restart the service. It didn't get the correct information as it started up and wasn't able to connect to the controller. So to do that, I go on this top screen. I have to open the search, get my keyboard, and search for services. Open up the services. And that'll open up, I'm going to look for Proplanner IoT service. And then click restart the service, and it'll go and boot the service back up. I can exit out of that and give it some time to start back up, and then hit refresh to get my device connections and just confirm that everything is connected. And then once I'm all set on that stage, I can just double check the operation by running through a process. But that should be everything to get the test bench set up.